Hello, this is Professor Salahat, and in this video here, we're going to try to do more problems from homework 5, and we're going to start with number 19. But before I do that, let me just give you a small introduction in here. We're going to be talking about proportions from 19 up, and I want you to remember that when we talk about a proportion, n will be called sample size. So keep that in mind. The sample size is n, but when we talk about proportions, we have a different name for n. We call it number of observations. In other words, it's the number of individuals or items surveyed. X will be the number of yeses or the number of successes. So let's say that you are surveying people about an issue. Every time somebody's like, say, do you agree, do you support, are you for, whatever, every time you hear yes, it is a success. Now, and the complement of yes is a no. So notice that in here, we try to find the proportion of yes. We call it the sample proportion by taking the x and dividing that by n. That's called the sample proportion. Now, the population proportion is called P without a hat. So this is a symbol in here. In the top there, it's called hat. So the proportion P without that symbol, the caret above it, is called the population proportion. And that is really our target, but we cannot get it, so we try to estimate that. Now the complement of P hat is called Q hat. And Q hat is 1 minus P hat. It's the complement. So if 40% said yes, then the complement will be 60%, because 100% minus 40% will give you 60%. So the Q hat is the proportion of the no. So let's go in here into the homework and try to see if we can work with this. So let me minimize this window here slightly and look at number 19 in your homework. I'll move this around if I can. I'll look at the problem. In the problem here in number 19, they are talking about, they say, let P be the proportion or the population proportion for the following condition. In a survey, so in this survey, N equal to 1902 from country A, and they said in here 752 or 754 actually, said that they were not confident that the food they eat in country A is safe. Okay, so in this case, probably the question was, do you think the food that you eat is safe? So that the answer would be yes or no. So 752 said that they were not confident. So that it'll be called the X. Now, in this case, if you want to find the P hat is always the proportion. So you divide X by N. So you're going to divide, again, the P hat is always X over N. So you're going to divide X, let me erase that. X will be 754, divide by 1902. And if we grab a calculator and do this math in here, is going to be like 0.396. So that is P hat. So we're going to go in here and we're going to just type the number in there, which is 0.396, and check the answer. And the answer is good. And we are expecting the second question in here, which is here. Okay, so the proportion of people who said yes is 0.396. So what do you think Q hat will be? By definition, Q hat is the complement, or it is 1 minus P hat. So it's going to be 1 minus 0.396. And if you do the math, it's going to be 0.604. So this will be 0.604. So that is what we have for number 19. Now, when we go to 20, let's see what the 20 wants. In 20, they are asking us to calculate, here, they are asking us to calculate confidence intervals for a proportion. So before I do that, let me make this window big and talk a little bit about that. To always find the confidence interval for a proportion, you use StatCrunch and you follow those steps. You're going to open StatCrunch and press the stat, then the proportion, go down to proportion stat, one sample with summary. and you're going to see two boxes to fill. One of them is called number of successes. One of them is called number of observations. Notice that the number of successes always is X, and it's a number. It's not a decimal. And the number of observations is always N. And then you're going to go down to the level of or confidence level, and you're going to fill that C in there in that box. And you hit the compute, and it should give you what you're looking for. So let's see if we can manage this one with this problem. Now here is a problem. In this problem, let me write the summary of the problem here, which is number 20. In number 20, they tell us in a survey of 2,461, that is N. In a recent year, 1472 said or say they have made a New Year resolution. In other words, this is the number of yeses, because the question probably was, did you make a New Year's resolution? And the answer is yes or no. So the number of the yeses is 1472. In the question in here, there are two requests actually. We want to build an interval for 90%, and we're going to build another one for 95%. So let's do the 90% first. Then we're going to go afterwards to the 95%. So I minimize the screen a little bit in here to make sure that you can see it. And I'm going to open StatCrunch to the side in here, and I'm going to follow those steps. Now we're going to go to Stat. We're going to go down to Proportion Stats, one sample with summary. Again, one sample with summary. And we click on with summary, and it says what's the number of successes. The number of successes, remember, X is the number of successes. You always start with X, which is 1472. Now, what is the number of observation? It's going to be 2461. Now, what if you flip them? What if you put the number of successes in place of number of observations? When you click compute, it's going to tell you it's an error. So you cannot do that. And now you're going to go to the confidence interval, and you make it 90% because that's the first request. In the first time, they tell us to use 90%. So I'm going to use 90% here, and I hit compute. And my first answer will be, for 90%, is going to be 0.58 187 something. And again, later on, we're going to come and see how many digits we need. And this is 0.6143 something. So again, I don't need all of those numbers. Let me just minimize this and see what we need. We need 3 decimals. So if I go to 3 decimals, it's going to be 0.58. And again, I need one more. It's going to be a 2. In second place, I need 0.61, and I need one more, so it's going to be a 4. So if I hit check, it's going to tell me, well done. Now, I need to change that level to 95%. Now, notice that if you're using StatCrunch, you don't have to do the problem again. You don't have to go stat, proportion stat, one sample with summary. It's already there. So let me just open StatCrunch and just click here on the option, then on the edit. You already have the 1472 and you already have the 2461. So you don't have to put them again. What you just need to do is just go down to the confidence level in here where the level is, and make sure you put it 95% and compute. And again, since they said they want 3 places for 95%, the interval is going to be 3 places, going to be 0.579 and 0.618. So we go here, the numbers in 0.579. Second number is 0.618, and double check, and it gives you the correct answer. Now, the question that follows will be, with the given confidence, it can be said that, now remember, anytime we talk about, we are not talking about the sample, we're talking about population. So it can be said that population proportion, not sample proportion, of adults who say they have made a New Year's resolution is, is usually the interval it always gives you between. So is between the endpoints. Remember, we are chasing the P, and the P is the population proportion. Now, so we want to say from this interval that this captures the true mean. So in this case, it has to be in between the endpoints. And if we check the answer, it's going to be good. Finally, compare the width of the confidence intervals. Which one is wider, the 90 or 95? Remember, we said this before, the bigger the confidence level is, the wider the interval. So the 95% is wider. Okay, always the case. 95 is wider than 90, 99 is wider than 95, and so on. I'm going to go to 21. And it seems like 21 is the same type of problem. In a survey here in 21, they tell us in a survey of 2320 adults, X, which is 749, say they believe in UFOs. So the question was, or is, do you believe in UFOs? Yes or no? So the ones who said yes are 749. The one who were surveyed or observed is 2320. So in this case, you want to use a C equal to native, or I'm sorry, native. It's the confidence level is going to be 95%, and we need to build in an interval here. So I go back to StatCrunch, and again, here are the steps that you need to follow. For a proportion, those are, let me circle it with this color. For a proportion, those are the steps that we need to follow. Okay, so it's the same step. Stat, proportion stat, one sample with summary. You fill in the number of successes, number of observations, confidence level, and you get what you're looking for. So let me just go to StatCrunch in here. And again, before I go, they want 3 decimal places. So here's StatCrunch. I go to stat, proportion stat, one sample with summary, and number of successes in this case. Let me just show you what will happen if I flip them. If I put 2320 here, and I put the 749 there. By the way, note, I want you to note that I am doing a wrong thing here. What I did is I flipped those two. I'm sorry, here. I flipped those two into StatCrunch. I put the number of successes 2320 and the number of observations 749, and the confidence level is 95. Let's keep it. Look what will happen if you make this mistake. It tells you it's an error, because we always need to put the number of successes and number of yeses. So you put the number of yeses in the number of successes, and you put the total, which is 2320, in the number of observations. So that is what you do. And if you do it this way, and again, don't forget the confidence level is 95%. If you do it correctly, you're going to get the answer you're looking for. And the answer in here that we have, we need 3 places, 0.304 and 0.342. So those are the 2 numbers that we get for the interval. So this is going to be 0.304, and the second number is 0.342. Now, if we check the answer here, it's going to tell us it's correct. Now, interpretation of this interval, what can we say? Notice that in the survey, we want to know about like if we are able to go and survey every single adult, we're talking about adults in here. Every single adult, let's say in the US, so the whole population, and ask them this question: do you believe in UFOs? What do you think the percentage of people who would say yes? Nobody knows, because nobody knows how to, or nobody can get to all adults in the US. So as a result, we did a small sample, a sample of 2,320, which is not a big sample compared to the population of the US. And I came up with an interval. Now, this interval is going to tell me about the confidence. It's not telling me about the percentage or anything. We can say with 95% confidence, we can say that, not this, notice in here, this part A doesn't talk about confidence, or actually it talks about confidence. The endpoints of the given interval shows that 95% of adults believe in UFOs. No. In this, it talks about probability, 95% of US adults. No. Now, B, C, and D. Now, the B talks about with 95% confidence. Lovely. C talks about with 95% confidence. Good. D talks about with 95% probability. Forget that because we're not talking about the probability. Now we are between B and C. Now with 95% confidence, it can be said in part B says it can be said that the population proportion. That is good. It talks about population proportion. When you talk about C, it talks about sample proportion. And we said that the confidence interval has to target the population proportion. Therefore, we choose the B. Again, we choose the B because it is confidence interval, and we talk about population proportion. And it is between, both of them talks about between. So we're going to choose the B, and this is the correct answer. Now, I'm going to stop in this video, and in the next video, we're going to talk about the remaining problems. So we're going to